Hello everyone and welcome to Danomics. In this video, we're going to cover making a porosity interpretation within Danomics. Let's get started. At this point, you should have already created your CPI file. You'll have set your key well. You want to make sure the key well is your active well, and you should have already performed the interpretation ready portion data of the workflow, done your clay volume and TOC analysis interpretation. And if you want to use the mineral inversion to determine your porosity, you should have already performed the mineral inversion as well. If you've not yet done that, I suggest going back and reviewing those help videos. So now to continue on with our porosity interpretation, we'll select porosity interpretation from the drop-down menu. Okay, there are a number of different methods that are available to you. So we have, for example, a neutron density porosity, a density porosity, a sonic porosity. We have two porosity options that use the mineral inversion. Those are the mineral inversion porosity and the strict version of the mineral inversion porosity. I'll explain those here in a minute. We have a deterministic grain density based porosity. And then we also have what we call a pecking order porosity, where it attempts to use the neutron density, and sonic methods in that order. In most cases, you'll choose to either use one of these first three methods. Often people will use a density porosity, as that gives a relatively robust answer across your field, especially when you're working with something like just a sandstone or limestone reservoir, or you'll choose to use one of the mineral inversion porosities. So let's start off by choosing our density porosity, and we'll take a look at some of the options that are available to us. So when we select our density porosity, it's now using a density porosity method, and we're going to click on advanced here so we can see all of the parameters are available to us. So what we see here is we have a rho B clean parameter, and this is our matrix density. And you'll see where we've selected limestone, our matrix density set at 2.71. Where we've selected sandstone, it's at 2.65. And in our organic shells, we set that value from our clay volume interpretation at around 2.7, or just underneath that. If you want to perform a TOC correction on your porosity, which is especially important for your organic shells, you'll want to make sure that you have this checkbox activated. Okay, so that gives us a calculation of our total porosity. And then if you want to use a total porosity, or an effective porosity, I should say, let's go in and set our clay porosity here. And I'm going to set this value to 0.1. So that adjusts our total to effective ratio. You may also want to go in and adjust your fluid density based on your salinity, and you can set a maximum porosity value. In this case, I'm going to set that to be 35%, and anything above that will be truncated. So that's one way you can perform this interpretation. However, if you've done the mineral inversion, you may want to use those results. To do that, we have two options. We have the mineral inversion porosity and the strict version. Let's start off with our mineral inversion porosity. What this does is it takes the grain density shown here in blue from our mineral inversion and uses that inside of a density porosity equation. It'll then use the rho fluid specified here, and it will calculate your total porosity, and then the total to effective conversion is done the same way it is for all of the other methods. The second option we have here is the strict version of the mineral inversion porosity. In this case, it uses the sum of the fluids specified in your mineral inversion module. So let's jump back to the inversion real quick here and take a look at that. In this case, we've specified that we have water and oil, and it will take the sum of the water and oil shown here in this track as our total porosity from the inversion, and it will use that as your porosity here in this interpretation. It's really up to you to determine which one to use here. I find that in most cases, we see a large number of petrophysicists using this mineral inversion porosity and then setting their own row fluid here. However, it's really a case of personal preference. Okay, so once we've done this, we have now made our porosity interpretation for our project, and we're ready to move on. If you have any questions about performing your porosity interpretation, please feel free to contact us at support@danomics.com. Thank you.